Welcome to my projectbasar.com. Now I am going to explain the detecting and locating faulty nodes in smart grids based on high frequency signal injection. Now I am going to explain the concept of this process. This is an effective protection scheme against high impedance faults, that is HIFs, as to efficiently confront the issues of reduction and location simultaneously. In this study, a novel approach for reducing FN and the procedure for localizing the position of the NN in a three-phase low-voltage complex distribution network is presented. This is the flow diagram of process that is reducting and locating faulty nodes in smart grids based on high frequency signal injection. First we go to the power generation. Power generation is nothing but we generate give power as the input. Then next we go to the control center. Control center means control the voltage. That's basically we design the distribution network. So in distribution substation we control the voltage, power. So for that we have to measure the current voltage in the specific meters. In the distribution substations we have collect all the powers into smart grids, that is small units, and it's commonly it's collected into the single large network, that is distribution substation. If then next we go to the satisfaction. If satisfied the above conditions, that is if the fault is occur means then it displays in 1. If the fault is not occur means it displays as 0. If the condition is satisfied means then it's finally connected to the load. If the condition is not satisfied means it's go to the initial process, that is control the center technique. Then finally our main motto is to detect the fault and locate where the fault is detected. If it's detected means when its fault occurs means 1 and fault does not occurs means 0. Thank you. Now we are going to see about the implementation work of this process. This is the MATLAB command window. For this process 7.9 version is used. For this, first give the input source, that is 3-phase source, and the next 3-phase source is given to the 3-phase transformer, and the voltage is passed to the 3-phase VA measurement. From this 3 VA measurement we noted the V value, that is 3-phase voltage value and 3-phase current value. Then next we use the transmission line. So for the transmission line we have to use the 3-phase PA section block. Then we create the subsystem, and in subsystem we include the fault identification node. That is if fault occurs means it displays 1 and fault doesn't occur means it displays as 0. For finally the 4 subsystems are created and the result is taken in each subsystem and deduct the faulty nodes. From this we conclude that a novel method for detecting localizing in a low voltage power line network is presented. The method to be run in a live network without any interference. The process is based on the power line network characteristics of the response of the network to high frequency test signal. Simulations based on 3 different scenarios have been implemented, demonstrated the validity of the method. The truncation of function of analog to digital conversion localizing the FN is identified. The dependence of the method on the resolutions smart meters are simulated. The method has to be validated with an experimental network developed in the laboratory. Experimental results show that the proposed method effectively detects and localizes the FN.